What we did is we used South African scientists, engineers, and tradesmen to deliver a South African product. So that's something significant.
My message would be that at one point of time, you have to transfer knowledge and expertise and IP that is generated in the bench scale within the university laboratories into some tangible and pre-commercial deliverables. And it's not possible without critical elements of the infrastructure. And this facility is exactly filling the gaps between laboratory research and deployment and incubation and commercialization of the technology. Let's be honest, HySA has been receiving funding from DSTI over 15 years, and as was mentioned today, across ecosystem of HySA, it's not only infrastructure, 1+ billion rand was invested, and it's time to go into the space of deployment. It's time to go in the triple helix framework when we work with industry, when we work with tertiary institutions. The HySA infrastructure at North University has multiple impactful achievements. It's not only student production, but also we were appointed by Mining Qualification Authority to take further our knowledge into the training all along the value chain of PGMs and hydrogen, artisans, technicians, master students, PhD students. That is going to happen at an accelerated scale now. To mention another highlight that is coming later this year, it's the outcome of the major project, international project with Japan under the SATRAPS framework. We are going to produce first in Africa green ammonia using green hydrogen. And this is really a big achievement. And again, that was with endorsement of Department of Science and Technology and Innovation, with endorsement of Treasury. This is happening. We're really moving forward towards the from research to the tangible demonstration and pre-commercialization activities. That is all happening with the help of this building, because without this RPTTF facility, you cannot work with containers, you cannot work with power tools, you need overhead cranes and other things like that to make it happen. This low-profile dozer runs on hydrogen and fuel cells. And you can see the aerial view of other section of our facility where hydrogen production storage is happening.
We really did good work with HySA, our Hydrogen South Africa infrastructure. And we are proud with the product that they created for us. So just give them a hand of applause for that. Very nice. So just a reflection, what you observe today is a demonstration of equipment that produce and fill our Toyota Mirai with hydrogen. Now that's the easy explanation of what you saw. What is more important, I could have bought this equipment from overseas easily. A lot less pain and frustration, but it would have meant nothing. We are not the first in the world to do this. Fortunately, the world has learned some lessons in this. So the difficult part in this project was to start the process of commercialization and to start to make it safe. So, well, let me make a short confession. I'm an industrial engineer. So what I'm about to tell you on safety and standards, it doesn't excite me, actually. I like the tangible things like hydrogen, making hydrogen, Toyota Mirai. The safety side or the standards, that for me is administration. But let me lower this to the man on the street. If you ask the man on the street about hydrogen, they'll look at you and say, hydrogen is a gas. Ne? Yes, but it's dangerous, ne? Isn't hydrogen that thing, that spaceship that blew up in the 1920s? No, I'm going to stay away from that thing. That's what people think. And it's for that purpose, for that perception that exists, that we need to do everything in our power to make this safe and adoptable for the normal South African citizen. He said that this is a first. We are pioneers. If you are a pioneer, you are under the scrutiny of society. One slip up, and the project of hydrogen in South Africa is dead. That you must acknowledge. So, What we started with Hydrogen South Africa was a slow process of starting with commercialization. That for me means you go from theory to paper, to a design, to a prototype, and then you have to certify it against standards. And that took a lot of time. But now we have a product with its own operating system, its own operating manual, and safety protocol. The best of all of this, somebody like myself without a PhD can operate that refueler. That is important. If we have these engineering marvels that can only be operated by people with PhDs, we haven't achieved our goal. Our goal is to make this equipment available to the normal South African citizen. We had to validate this equipment against several international standards. 10 HySA standards, 4 standards from the Society of Automotive Engineers, 6 specialist standards from the American Society of Mechanical Engineers, and from the National Fire Protection Association, and from the Compressed Gas Association, 11 combined standards for American National Standards Institute and the National Standards of Canada, 6 standards from the South African National Standards, 5 combined standards from the British Standards and International Electric Technical Commission. All in all, that equipment is certified against 42 international standards. So I can say, I think it's safe now. So the delegates, especially involved in funding from the various government departments, please don't stop your programs. Please don't stop your funding. Continue to invest, and then you'll see the participation from the private sector. Thank you very much.